What's going on, my ASVAB party people? Anderson here, your ASVAB coach, with another treat for you. We've got a 2-hour class on proportions and proportion word problems. That way you can keep raising your score. So 3 main things that we're going to go over in this video. 1, what's a proportion? I think a lot of us have an idea, but let's understand the exact definition and how to understand them fully no matter what. 2, how do we solve proportions? I know a lot of us may have learned in middle school and high school, cross, multiply, and divide. But the thing is, that's not the fastest way. I'm going to show you multiple techniques. That way you can pick the one you prefer so you can perform problems as quickly as you can. And number 3, how to set proportions up in word problems. This is way too important, this last one, because solving word problems is part of the arithmetic reasoning. If you can raise your arithmetic reasoning score, every single one of your scores, your line scores, will technically go up. So this is way too important. I'm going to show you exactly how to get this done in a pretty fun way and not like reading out of a textbook. And so with that said, my party people, 2 things before we begin. 1, please make sure to like this video, subscribe to the channel, and comment on your favorite part of the video. By doing that, it helps put us out there in front of more viewers. That way we can perform and keep to our mission of helping other people succeed, just like you. And number 2, if you like what you saw in this recording, then consider subscribing to the All-Access Pass. Basically, it's my program that helps all of my students succeed with 3 main benefits. 1, you get direct access for me to ask any questions. That way, you're never stuck and you can keep raising your score. Number 2, you get access to all of the classes and the recordings. There's over 200 recordings ready for you to watch whenever you're ready. And number 3, you get over 1,000 practice problems. That way, your confidence only keeps going up and you can watch video solutions to keep understanding what you're doing. So, if you're interested in that, watch the recording first. And if you're ready to go, check the description of the video for the link to sign up or my phone number. That way you can text me or call me if you have any questions at all. Look, at the end of the day, I want you to get the score you want. That way you can get the military job you deserve. And that starts with putting in the effort now and raising that score. So if you have any questions in the meantime, go ahead and let me know. But without further ado, that's the ASVAB. Let's get to it. All right, my party people, let's go ahead and dive on in, man. Let's dive on in. So, main notes here. I want everybody to go ahead and take a screenshot of this. So today we're going to be going over a few different types of ratio proportion problems, specifically proportions. And before we even begin, we got to understand what the hell we're talking about, okay? That's the first thing about any concept. Before you start tackling problems on something you don't know, before you let that frustration overwhelm you and tell you, yeah, that's too hard, I don't want to try that. Before you get into all that, understand the main theme, the main idea, kind of like the concept or the purpose behind these issues. So what the hell is a proportion? Basically, the main note that I'm going to make you and force you to repeat and repeat and repeat throughout this whole class is this: comparing the same things in the same way. That is all you need to understand about proportions. This is basically your purpose when it comes to proportions. We are comparing the same things in the same way every single time. I'm going to go deeper and explain what that means. But again, everybody, this is our only concern right now. Proportions compare the same things in the same way. That's all we got to worry about right now. And so let's go and truly actually like formally define proportions. Because if we take our eyes right over here, what are proportions right over there? If we take a look right here, basically what a proportion is just 2 fractions that are the same. That's it. This equals this. That's it. That's it. Just 2 fractions that are the same. So let me go ahead and just give you a quick example in terms of what I mean. Everybody, if I were to go ahead and take 1 divided by 2, is that the same thing as 0.5?
Yes.
Yeah.
1 divided by 2. Right? I think we can all agree that that's going to be a yes. And if I grab my calculator right here, which obviously you can't use on the ASVAB, but let me just prove it to you. 1 divided by 2, you probably can't see it, but it does say 0.5. All right. Now, if I were to say that 1/2 is equal to, if I were to say it's equal to 5 divided by 10, would that still be true? Like, these are different numbers, but is 1 divided by 2 the same thing as 5 over 10? Is it?
Yes.
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 Yeah, it absolutely is. I think we can all agree there, because if you take 5 divided by 10, what do we get in that calculator if we plug it in?
1.5.
Yeah, we get 1/2. We get the same thing. We get 0.5. We get 0.5. And so I hope that you can see here that although the numbers are different, they are literally the same fraction though. You guys ever realize, like back when you're doing fractions, when they say change the denominator before you add or subtract, you're not really changing the value of the fraction. You're just changing the way it looks. And so when it comes to proportions, all we're doing here is comparing two fractions that are the same, comparing the same things in the same way.
I didn't know that. I didn't know that back in high school.
Hey, that's what I'm here for, to make dreams come true. So let's go ahead and let's get to it. So again, that's your first example there. Right over there, you can see it. We have 1/2 is the same thing as 5 out of 10. And that's all proportions are. Fractions that are equal, that mean the same thing. So let's go ahead and move forward here and dive a little deeper though. So another way that I like to explain it is by saying that they're the same parts of the same wholes. So for example, when you take a look here, 1/2, everybody, is it safe to say that 1 is half of 2? Like just, yeah, exactly.
Yeah.
1 is half of 2 because 1 times 2 is 2. Yeah, cool. Now, again, is 5 half of 10?
Yeah.
No.
It is. 5 is half of 10. You cut 10 in half, you get 5, right? You cut 10 in half, you get 5. That's all I'm saying here. That is all I'm saying here. They're the same parts of the same wholes. The parts are half of the whole here. And you're going to see
I get it now.
It could be a third, could be a quarter, could be a fifth. It could be whatever. But as long as they're being compared in the same way, it is a proportion. It is the same comparison in the same way. So with that said, Andrew, absolutely. You can use 2 out of 4, 3 out of 6, 4 out of 8, 6 out of 12, 7 out of 14, 8 out of 16. For this specific example, anything where the top is half of the bottom would work. Anything. So let's take a look at an example here, because there's nothing worse than your teacher just giving you notes and then being like, all right, go practice. There's nothing worse than that, right? So let's go ahead and actually understand some examples. So first example here, taking a look, there is 1 boy for every 2 girls in class. If there are 12 girls in class, then there are 6 boys. Okay, watch as I show you how to set something like this up. So a lot of people, and you tell me if this sounds like you, have you ever tried to set up a proportion only by going by the order in which the numbers show up?
Yes.
Like not even paying attention, just going by the order, like, oh, 1, 2, 1 divided by 2, 12, 6, 12 divided by 6.
I start with a big number.
Hey, that happens. Again, that can happen, but let me tell you why that is the wrong case here. Okay. When it comes to proportions, it is not about just grabbing the numbers in order. It is about representing them in the same way. Remember, what did I say here? What did I say here? Compare the same things in the same way. That is the cardinal rule of proportions. Let me show you what I mean here. And so for a quick moment, I want to go through this one because I'm going to clip this for YouTube. So I'm going to mute everybody real quick. All right. So again, compare the same things in the same way. That's all you got to worry about. Watch this. There is 1 boy for every 2 girls in class. All right, cool. So if I were to go ahead and write out 1 divided by 2, again, we already said that the 1 represents boy and the 2 represents girls, right? Cool. Now, let's go ahead and move over here. What about the right side of this proportion? Like, how are we actually going to set this up? Well, let me show you here. We got 12 what here? 12 what? Girls or boys? 12 what? Right, we got 12 girls here. We got 12 girls in class. And so when we set this up, should the 12 for the girls go on the top or the bottom? What do you guys think? Go ahead and type it out in the chat box. What do y'all think? Should it go in the top or the bottom? What do y'all think? What do y'all think? Okay, I see some answers here so far. Again, give your honest opinion. I want to see everybody participate here, man. Everybody needs to participate. Natalie, I love that you gave your answer and the explanation here. Natalie says the bottom because it needs to be the same. The same what, everybody? What's that C word? Needs to be the same what? Needs to be the same what? Needs to be the same comparison. Exactly. Needs to be the same comparison. So if we check this out and we want to put the 12 girls somewhere, it's going to have to go on the bottom because you see that the girls are already on bottom here. And so then when you see the 6 boys, we will place that on the top. Now look at how this is perfectly done. This is compared in the same way, my party people. Look, just take a look. Everybody, 1 is half of 2. Is 6 half of 12 though? Yes or no? Absolutely right. 6 is half of 12. And that's how you know that you have a proper proportion with the numbers. Let me show you how it's not only important to know how to set it up with the numbers, it's actually really important to know how to set it up with the words. Because remember, everybody, the numbers in a problem don't mean jack crap. They don't mean anything until you know what they mean. The numbers don't matter until you know what the numbers mean. And so let me just go ahead and kind of walk you through this. So look at this. Here on the left side, we have boy over girl. On the right side, we got boy over girl. So we already know that the comparison is being done in the same way. This is from the first sentence. Here's from the second sentence. You're good. You know that this is a proportion because you've compared the same things, not the same numbers, the same things in the same way. And I got a message here, a direct one here, saying, what if it was an odd number like 6 over 5? We'll absolutely be dealing with questions like that. I gotcha. So let me also show you guys how to understand that numerically, like with numbers, this works out just fine too. Everybody, what was that way that they told you to solve proportions as a kid? What was it? It started with a C, then ends with an M. What did they say? Let me give you all the mic again.
Comparison.
Cross multiply, then divide.
Cross multiply, then divide. That's right, yeah. Yeah, that's right.
What she said.
Yeah, cross multiply and divide. All right, cross multiply and divide.
Oh,
That's how we were taught in school, or most of us were taught in school. But don't worry, today we're going to go over multiple methods. But let me just show you this. If I cross multiply, 1 times 12, everybody, quick is what?
12.
Okay. And then if I go the other way here, what's 2 times 6?
12.
12.
Wait, great. Do you see that 12 equals 12? And that's why cross multiplying and dividing works. Because when you cross multiply, you'll still have a true equation. You'll still have a true statement. And when you can work on a true statement, you can always find an answer. So that's the idea there. Does that make a little more sense to everybody in terms of why the hell cross multiplying and dividing works?
A little bit, but yes.
Cool. And we're going to be going over plenty of examples today. I got y'all. I absolutely got y'all. I'm really excited, man, because today I'm going to show you 2 different types of proportion problems. One that y'all are used to. One is one that gives everybody nightmares. But I'm going to tell you right now, as long as you follow that 1 cardinal rule, you are going to be fine, man. You are going to be fine. As long as we compare the same things in the same way, we'll be fine. So let's go ahead and have some fun here. Let me guide you through a warm-up here. First off, like I told you in the beginning that I'm going to show you how to actually solve them as well in more than one way. So with that said, someone call me. All right, I'm going to make sure I mute y'all real quick because I got to make sure I get no feedback there. Yeah, Justin, that's correct. Justin Wilson. Yeah, we got to make sure that we can get the fractions the right way equal to each other. But let me go ahead and show you how to solve proportions. So like we were taught, I mean, the boring way, in my opinion, was cross multiply and divide. Let me walk you through. Everybody help me out. If I do 8 times x, what is that going to be equal to? Hit me in the chat box. 8 times x gives me, who's awake? Let's go. Yep. 8x. 8x. Now, let's go ahead here and do 6 times 16. Does anybody here know what 6 times 16 is off the top of their head? Anybody here off the top of their head? Like if you just look at that, like, yeah, I'm good. I do this for breakfast. I know some people here using that phone calculator. I know some people here using that mental math. Alonzo splitting glue. That's right. And so if you've been to my classes, you know how to do something like this pretty quick. But for the majority of people, yeah, you gotta write it down, Morgan. That's right. It's all good. It's all good. So if you go ahead and do it, you can do 16 times 6, and you get 6 times 6, 36. 1 times 6, that's 6 times 3, or plus 3 is 9. So you get 96. All right, cool. Then what you're going to do is you're going to go ahead and do what now to solve for x, everybody? What are we going to do once we have 8x equals 96? Be specific. What do you mean divide? Come on, be specific, everybody. That's right, Mario. Divide by 8 on both sides. You got to be specific, everybody. You got to be specific. Thank you, thank you, thank you. There we go. Keep it up. I love it. So divide by 8 on both sides. Divide by 8 on both sides. So what's going to happen here is on the left side, this is going to cancel out. That's going to cancel out right there on the left side. And once we do that, we're going to be left with that x. And then we got 96 divided by 8. And unless, you got to know your mental or your times tables here, because 96 is 8 times 12. And so the answer here will be 12. So let me just introduce you to that right there. Again, everybody, on a scale of, on a scale of 1 to 10, with 10 being super, super easy, 1 being, no, this is still super hard. On a scale of 1 to 10, like how easily understandable was that? Cross multiply and then divide. Cross multiply and then divide. The majority of us are saying, hey, that was pretty understandable, right? Pretty understandable, super straightforward. Some of us are even saying easy. Some of us are saying it's coming back. I hope you don't mean the PTSD of math, but yeah. Okay, so let me go ahead and kind of like recap that. We had to cross multiply. We had to multiply some big numbers there to get 96. Then we had to divide a big number by a number and get the answer. So notice how we ended up doing 2 big operations. Everybody, this is what happens when you come to my classes. Let me go ahead and show you what's up. We're going to do the exact same problem right over here. This is how the true way to solve proportions should have been taught in school, especially when you have what's called a convenient situation. This right here is a convenient situation. How do I know? Watch this. Everybody, we said that the cardinal rule, what was it again? Everybody type it out again. The cardinal rule for proportions was what? I want everybody to type it out before I show you this. Type out that cardinal rule right there. Type it out, type it out, type it out. Type it out, type it out, type it out. Hey, Alexia, go ahead and hit me up in via text. I'll answer that for sure for you. I got you. But I want everybody to type it out here. Compare the same things in the same way. You are going to thank me at the end of class. I'm telling you right now. You know I'm going to sound annoying. You know how I do things. But at the end of the day, your success is what you're going to get. That's what you're here for. Compare the same things in the same way. Compare the same things in the same way. Everybody type that out. Let's go. We got about only 20 so far. I will wait. I will wait. I will be that dude. Multiply or compare the same things in the same way. Thank you, Journey. Appreciate that. Thanks, Karen. Thanks, Trinity. Thanks, Gene. Thanks, Justin. Compare the same things in the same way. Natalie. Same way, same way, same way. That's right. All right. So let me show y'all here. We can compare with proportions. We can compare top to bottom. We can compare bottom to top. But one thing you didn't know is that you can compare side to side. You can compare laterally. You can compare it like this. Why would I even want to do that? Let me show you something, my party people. Look at this. Everybody, what do I multiply 8 by to get to 16? What do I multiply 8 by to get 16? Right? You multiply by 2. Exactly. I multiply by 2. Everybody, what happens when I multiply 6 times 2? What do I get? Oh, look at that, man. Look at that. Wow, 12. Let me use a different highlighter here. Wow. Whoops, wrong one. Look at that. We get 12. Wow. Wow. Did we just do the same problem with literally one step? Yeah. So there's that. So this is typically where a lot of people are like, wait, what the hell? And yeah. So, yep, that just happened. That literally just happened. We have to learn how to spot convenient situations in math. But to do that, you need to understand how the math actually works. Remember, proportions are comparisons in the same way. If you know that rule, then you can go from the beaten into our heads method of cross multiplying and dividing to simply looking at this as a comparison. Oh, to go from 8 to 16, you times 2. So that means to go from 6 to the answer, times 2. That's how you get 12, and you're done. And that's it. And that's seriously it. As long as you compare the same things in the same way, you're good. But let me be honest. Everybody, yes or no? Is every situation going to be this convenient? Is every situation going to be this convenient? No, not every situation. But there are times where you'll be able to use this very, very, very easily. And we got to be able to spot those situations. So let's turn our attention over to another example here. So what we have here is m over 21 equals 12 over 14. All right, so let's check something like this out. Everybody, first and foremost, let's work to really understand the answer. Now, here's the regular way to go about it. We're going to go ahead and cross multiply. M times 14, hit me, everybody, quick. M times 14 gives me, Aldine hit it with the first time there. Yep, 14m. And then when we go ahead and take the 21 times 12, who knows that off the top of their head? Probably nobody. What does 21 times 12 give us? Right? And so you look at this and you're saying, wow, like I'm already trying to do big math. Like what the heck is going on, right? I'm already trying to do big math. This is not fun for me. So if we do it, let me just show you. 21 times 12. If you try to do it, look, this gets annoying. Like just look at this. 1 times 2 is 2. 2 times 2 is 4. Bring the 0. 1 times 1, that's going to be 1. 2 times 1, that's going to be 2. Add it back together. And we get 252. So notice how we just had to do all that work to just figure out it's 252. And then now what we got to do is divide this whole thing by 14. Again, is anybody here sitting here like, yo, I wish there was an easier way? Anybody here at all? Yeah, I would assume so. I would assume so. Because when you divide by 14, then you got to go ahead and say, okay, 14, 252. 14 goes into 25. It goes in there one time. So you subtract 14, then you get 11. And now you're sitting here like, oh my God, I don't even know how many times 14 goes into 112. Why are you asking me that question? Right? We're sitting here like, yo, sweet Lord, baby Jesus, what is going on? And we don't want to feel that way, right? We don't want to feel that way, but what you're going to know is the answer is 8 eventually after you beat your head against the wall a couple times, and you'll get 18. So again, I wish there was an easier way. And let's figure it out. So let's take a look here, everybody. We got m over 21 equals 12 over 14. Everybody, do you notice anything about the right side of this equation? Who notices anything about the right side here? Type it into the chat box. What do you notice? What do you notice about this right here? What do you notice? They're both even. And if you have a fraction that has a number that can go into both the top and the bottom, you can perform what's called an S word here. You can do what to the fraction? You can, what's the S word there that I'm looking for? Simplify. That's right. You can simplify. So let me write this out for y'all. I got y'all. You can simplify in the same way that you compare. In the same way that you compare. Again, read that again. You can simplify in the same way that you compare. You can simplify top to bottom, side to side, top to bottom, doesn't matter. You can simplify any which way you want. So with that said, everybody, what goes into both 12 and 14? Yeah, it's 2. It's 2. So I'm going to go ahead and divide the top by 2 and the bottom by 2. Because remember, with fractions, whatever you do to the top, you do to the bottom. Whatever you compare by, compare in the same way. So boom, if we divide both the top and the bottom by 2, let's go ahead and see what we got here. Everybody hit me. 12 divided by 2. Easy question of the day. 12 divided by 2. That's right. It's going to give me that 6 right there. It's going to give me that 6. And then 14 divided by 2. What's that going to give me? Absolutely. That's going to give me that 7 right there. So now that we have it like this, who here thinks that it'll be easier to now go ahead and cross multiply and divide? Right? So much easier, right? So much easier to cross multiply and divide. But let me hit you with some facts real quick. Hey, compare the same things in the same way now. Guess what? I'm looking at this and I'm saying, 7 times 3 is 21, right? 7 times 3 is 21. Everybody, what's 6 times 3? Ooh, 18. M equals 18. So do we see here, again, comparing the same things in the same way will allow us to get problems done much, much, much faster. Are we starting to see that? Yes or no? Right on. And I'm going to address some questions here. I see some people that are still confused, and I got you. Don't worry. So I see up here, someone asked, let me see, where was it? So why did you divide to simplify? I'm lost. So Maya, hey, no, that's a great question. So the thing about fractions is that you can simplify them to deal with smaller numbers. So for example, Maya, if I said that I had, let's say 50 out of 100, if I said 50 out of 100, isn't that the same thing as just saying half? Because 50 is half of 100. Is it the same thing? Right? Isn't that right? Yeah. And so that's the idea. The idea is to simplify. That way you can give yourself an easier set of numbers to deal with. Because if you're dealing with 50 and 100, I think it's a lot easier to deal with 1 over 2. 1 over 2 is the same thing as 50 over 100. So it's so much easier to use smaller numbers. And that's what we did here. Because you still could have actually gone and cross multiplied and divided to give yourself an easier time. You could have. That still would have been easier than dealing with those original numbers. And we're going to get plenty more practice, though. I got you. This is just one of many examples we're going to go through today. One of many. So allow me to go ahead and take you through another proportion here. Let's take a look at this. We have 12 over 21 equals 4 over y. No, it wouldn't matter, Mario. Still would work. As long as you set it up appropriately, wouldn't matter. I'm going to give everybody here 1 minute to solve this problem. Don't give it away. Just type ready in the chat box when you're ready. Here's a minute starting now. Go. Again, type ready when you're ready. Don't reveal the answer. Just try this one out. Just try it out. Yeah, Maya. And you can, again, as long as you are multiplying or dividing, but typically to simplify, yeah, you're dividing. Yeah. So again, everybody, just type ready when you're ready. Just type ready when you're ready. Just try your best, guys. Again, just try your best. I know I'm giving you a timer here, but I just want you to try your best for that whole minute. It's pretty much like exercising with your brain. That's all it is. All right. So we're looking at our final 3, 2, 1. Everybody give your answer. Take a guess if you don't have an answer. Take a guess. It's all good. Put a question mark next to your guess. Stop looking at the chat box, seeing all those 7s and putting a 7 because you think it's 7 now. Come on. Don't be that person. Go ahead and just give it your best shot. Let's go. All right. So a lot of us have the answer as 7. I need a new chair, man. All right, so where did my pen go? Let's get to it. So when you look at something like this, did anybody here do 21 times 4 to get 84, and then 12 times y to get 12y? Did anybody here start that way? I gotta be honest. If that was you, right? Because this might be doable enough because we might be able to see this and say, okay, now we're going to divide both sides by what now? Divide both sides by what now? By 12, right? We're going to divide both sides by 12 to really get the answer. And so when we divide by 12, Again, it's going to cancel here on the right side, giving us y equals, and if you know your multiplication tables, we'll just go ahead and say that that's going to be 7. Okay, cool. So we were able to cross multiply and divide the traditional way. And yeah, we were able to get it done for sure. You can absolutely get it done. But let me prove to you that, again, there are better techniques out there. So let's take a look at the 12 over 21 equals 6 over y. Okay, if I try to do this in terms of comparing the same things in the same way, what do we notice? Everybody, how do I go from 12 to 4? What do I do to 12 to get to 4? What do I do? Now you're saying 3, but what operation are you doing? Is it multiplication or division? Because either one can work. Which one is it? Divide. That's right. It's going to be divide by 3. Divide by 3. So if I look at 12 to 4, the comparison is divide by 3. Now remember, everybody, we are comparing the same things in the same way. One more time. We are comparing the same things in the same way. So how are we going to go from 21 to y, everybody? By dividing by. That's right. We are comparing the same things in the same way. So we will divide by 3. And so 21 divided by 3 is what, my party people? That's right. That's right. So now I've introduced the idea, again, that the comparison, the whole comparing thing, comparing is done with multiplication or division. Remember, multiplication and division are actually the same operation. Just like adding and subtracting are the same, like adding you move forward, subtracting you move backwards, multiplying, you're grouping, and then dividing, you're basically seeing how many groups. They're the same thing. They're the same thing. And so I see Peggy had a question. Let me go ahead and give you the ability to unmute yourself. Go ahead, Peggy. What's your question?
Okay, Coach. What if when you do it in by multiplication instead of division? Can you go by what will 4 multiply to give you 12? Then you get maybe 4 times 3, that is 12. And then since you use the 3 up, then you ask yourself, what number times 3 will give you 21?
Yeah.
7.
That is literally, yep, that is absolutely 1000% correct. Yeah, you're good. Yeah. And that's the idea, because when you think about, oh, what number times 3 gives you 21? That's the same thing as saying 21 divided by 3 gives you what? Same exact thing, right? Same exact thing. And so there it is, my party people. Again, you can do it with multiplication or division. But before we continue, let me make sure you guys know the 3 steps to solve proportion word problems, because we're about to go into word problems here. So here's the word problem that I'm going to show you. But let me make sure everybody here has the 3 steps to solving word problems. Let me write this down here. 3 steps for proportion word problems here. All right, so 3 steps right here. So 3 steps. 1, basically the setup, okay? Step number 2, simplify if you can. And step 3, solve. These are the 3 steps here. These are the 3 steps. If you want to, learn how to become faster and faster at proportions and proportion word problems, it's going to be all about setting it up, simplifying it, and then solving. If you try to go straight from setting up to solving, chances are you're dealing with bigger numbers than you need to deal with. We don't want to deal with big numbers, everybody. If you can simplify really quick, simplify. Give yourself an easier time. If you are one of my returning students, you guys know how big I am on mental math. And really what mental math is simply taking one big operation and turning it into a few different, smaller, easier operations. That's all it is. Same thing here. You set up the proportion. It's a big one. Let's go ahead and take, instead of one big step, cross, multiply, divide, let's break it down and let's simplify first to deal with smaller numbers and then solve it that way. That's the idea. These 3 right there, set up, simplify, solve. The 3 S's to solving proportions. That's it right there. So let's go ahead and let's solve this problem here. This is a guided one. Let's go ahead and get to it. So it says here, 6 papayas cost 18 bucks. How many papayas can you buy for $54? So typically when it comes to word problems, I tell you to read the question first, and we'll get to that. But let me just go ahead and really go through this one for you and help you really get your feet wet. So everybody, what is it that we're looking for in this problem? Let's go ahead and make sure we identify what we're solving for. What are we solving for? Right, so Aldine, Adam, Marie, Mario, Peggy, papayas, the amount of papayas. Okay, so what is that amount of papayas connected to? So I'm going to say it's right here. So how many papayas? So blank papayas for $54. That's right. It's connected to the $54. So for $54. Okay, cool. So far, we know that we're looking for a certain number of papayas for $54. Okay. So everybody, what letter should I use for papayas? What letter should I use? Yeah, P for papayas. That's right. It's an easy letter to use. Let's just use P for papayas. Let me just use it in black there. P for papayas, whatever. All right. So with that said, now let's look at the information that they give us. Because you see here in the beginning, they say, hey, 6 papayas costs $18. 6 papayas cost $18. Okay. So let me set that up here. 6 papayas. And for how much money was 6 papayas? For 18 bucks. That's right. For $18. So before I even begin, let me just take a quick survey. Everybody answer this question for me, yes or no, in the chat box. Please only answer once. Yes or no. Are you able to see how with these 2 statements I made, we are comparing the same things in the same way? Papayas and their cost, papayas and their cost. Do we see how we're comparing the same things in the same way? And there we go. So if you guys want to know what a papaya looks like, let me do this really quick for you. I'm going to go ahead and just copy and paste what a picture of a papaya looks like. Basically, it's just a food that you eat, papaya. Right here. And technically, it's a fruit. Some people call it a vegetable, but it's a fruit. So let me copy this. All righty. 3, 2, and 1. Oh, it's not automatically connected. I wish it was. For some reason, whatever. I was going to show you guys a picture of a papaya, but it's all good. But basically, a papaya is a fruit. That's all I got to know. But long story short, everybody, we have the same comparison in the same way. That's all we care about right now. And so this is how we're going to set up the proportion. You can set it up like this. P over 54 over, or equals, 6 over 18. That's one way you can go ahead and set it up. Because you see here that we have 6 to 54 right there. We also see that we have 6 to 18 right there. Again, it is all about comparing the same things in the same way. As long as you do that, you're fine. You're fine. Now, let's go ahead here and ask ourselves, everybody, is that the only way to set it up? Yes or no? Is that the only way to set it up? No, it is not the only way to set it up. It absolutely is not. Absolutely is not. There is more than one way always to set it up. As long as you're comparing the same things in the same way, you're good. Watch this. Let me show you here. You can go ahead and do this. I can say, hey, P over 6 equals 54 over 18. That's another way you can set it up. That is absolutely another way you can set it up. Absolutely. Again, as long as you are comparing the same things in the same way, you can set up proportions however you want. Literally, however you want. Doesn't matter. You can do, if you wanted to go about it like this, you could say with purple here, 6 to P, 18 to 54. So many different ways. All right. So I know I'm sounding boring right now and getting into that details and stuff, but seriously, as long as you're comparing the same things in the same way, you're fine. You're fine. Just make sure that you are doing that. Okay. Comparing the same things in the same way. So without further ado, let's go ahead and solve this. Let's give ourselves an easier time here. So my party people, let's ask ourselves first and foremost, we got the setup. So we checked that off. All right. Can we simplify, everybody? Let's focus on the one in black. Can we simplify? Can we simplify anything? Well, what can we do? Which side? The left side, the right side, simplify top to bottom. Like, what can we do? What can we do? What can we do? Right, we can simplify the 6 and the 18, right? Because 6 and 18 are both divisible by what? What are 6 and 18 both divisible by? Right on. Yeah, they're both divisible by 6. So let's go ahead and do that here. 6 divided by 6, 18 divided by 6. So let's simplify here. If we simplify, we're going to end up getting P over 54 equals, everybody, 6 divided by 6 is, help me out. Correct. And then 18 divided by 6 is correct, 3. All right, cool. And so we were able to simplify. And now that we were able to simplify, now let's go ahead and solve. Now let's give ourselves an easier chance here to get this done. Now, if you notice, oh, we can divide by 3, hold that thought right now. If you're looking at this and you're saying, oh, I could divide by 3, hold that thought. Let me show you why that makes sense. So let's cross multiply here. Everybody, P times 3, give me. P times 3 is 3P, correct. Everybody, 54 times 1 is, ooh, that's pretty hard, right? That's pretty hard. 54, that's correct. All right, what's the last step we're going to take? What are we going to do? Be specific. Be specific. There we go. That's what's up. Be specific there. Yeah. Divide both sides by 3. Divide both sides by 3. That's exactly what we're going to do. 3 and 3 right there. And so, oh, hold up. Remember earlier when we were looking at just this? Oh, 3 divided by 3 gives you 1. So 54 divided by 3 is going to give you the answer. Oh, 54 divided by 3 is going to give me my answer. So do you guys see how we're using that compare the same things in the same way thing? That's literally just proportion mental math. That's literally all that is. I'm just teaching you how to think about it in more than one way. That's all I'm doing here. Just teaching you how to think about it in more than one way. And you're going to find a way that works for you. Because once we do that, the 3's cancel, leaving us with P equals what? 18. That's right. If you wanted to go ahead and take care of business like this, all right, 3 goes into, 3 goes into 54, 3 goes into 1 or 5 one time. 3 goes into 24 8 times. And so you can get that 18 and you're good to go. And we're good. All right. And so at the end of the day, everybody, what is the correct answer? That's right. It's going to be B. It's going to be B, 18. So what's going to happen next is I'm going to basically release y'all into the wild. I'm going to go ahead and give y'all a few problems to try out today. So it's about 7 o'clock right now. So we have an hour left, got a bunch of time left. So I'm hoping that we can get through all of the problems that we got. But let me make sure you understand how to really get this done without freaking out or letting that anxiety get in the way. Number 1, the first thing you need to do, and I'm going to give you guys the mic here because I want everybody to answer this if you know the answer. Everybody, the first step to every single word problem is to
read the question first.
Read the question.
Coach.
Read the question. Every single time.
Coach.
The first thing we need to do, one second, Jose. The first thing we need to do is read the question. And remember, if you have a question or you need to ask something, please make sure to raise your hand first. That way I can go ahead and make sure it goes uninterrupted. But yeah, Read the question first is what we're going to do. Number two, we know we're dealing with proportions. So remember to follow the 3 steps right here. Get the setup right, simplify, and then solve. If you get those 3 things done, every single problem, I can bet you right now $1 million that even if you don't get the problem right, you will understand why you didn't get it right. That's the main point here. If we're here and learning and growing, it's about learning why. So Jose, what's your question? And then we'll go to Mikhail after that.
I have a question. Like you're saying about setting up, it doesn't matter how you set it up, do you? Or is there a certain way that you have to do it to set it up to get it right? Or
yeah, you have to be very careful to compare the same things in the same way. If you're not comparing the same things in the same way, it won't work. So there are going to be plenty of examples where I'll show you the wrong way to set it up and the right way.
okay, because I'd set it up wrong, I think, because I put P/6 and then 54/18, and I was doing it, and I got like a whole nother answer.
I mean, if you do P/6, 54/18, you'll still get the same answer. You should still get 18. So maybe the math might have gone wrong a little bit. So that's fine. You can send me your work and I'll check it. Mikhail?
Yeah, I'm just trying to understand how come we didn't divide by 3 instead of dividing by 6.
So for 6/18, right over here,
Yeah.
you could divide by 3. But if you notice, I mean, it makes more sense to divide by 6 because you deal with smaller numbers.
Okay.
If you divide by 3, you'll get 6 divided by 3 is 2. 18 divided by 3 is 6. So would you rather deal with 2 and 6 or smaller numbers like 1 and 3? You see where I'm coming from?
Yeah, I get where you're coming from.
Yeah. So it's all about giving yourself the smallest numbers to deal with for the easiest time. Great question, though. Kiara?
So you're saying as long as the numerator and denominator are comparable and you do the math right, you'll always get the answer correct.
Yes. As long as you compare the same things in the same way and solve, with the right calculation. Yep. Every single time. Because the thing is, so many of us know how to calculate, but not everybody here knows how to set it up. And if you set up with the wrong numbers, even though you can calculate quickly and correctly, you'll still get the wrong answer because you didn't set it up the right way.
Right. So like, let's just say you did 5 and 7, the answer is going to be wrong because it's not comparable, basically.
No, the numbers themselves are not the issue. It's what the numbers mean. And that's why we're going to get into these word problems today. So hold that thought right there because I know exactly what you're trying to say. And I'm going to show you why it's all about the setup here in terms of the wording, not the numbers. I got you. And so with that said, let's go ahead here. Let's turn our attention over. Let me go ahead and give you guys an ability to mute. Boom. All right, cool. So I'm going to give you all 2 minutes per question here. Let me get my timer set up. When you're ready, when you have an answer, simply type ready in the chat box, right? Just type ready in the chat box and we're going to move forward in the right way. 3, 2, 1, let's go. 2 minutes exactly. And again, type ready when you're ready. Don't reveal the answer. All right, we're looking at our final 10 seconds, but let me just make sure I go over again what the goal is right now. My goal for you in the beginning here is to simply be able to set it up. All right. Now, when it comes to calculating and working quickly when you're learning something for the first time, obviously that's going to be hard to do, especially when you're being timed on something you're not quite confident in. So everybody go ahead, type your answers in. And if you are taking a guess, if you're out of time, put a question mark next to your guess to let me know that you didn't quite finish. And that's okay. It's just for me to know where you're at. So 3, 2, 1, everybody give me your answer. Go. Give me your answer. Let's go, let's go, let's go, let's go, let's go. Again, put a question mark next to it if you're not quite sure. If you're not quite sure, and that's all good. All right. So let's go ahead and let's really, again, work to really understand this. Let's work to really understand this. So the first step is obviously to really read the question. And so everybody, what are we looking for? What is this question asking us to figure out? Let me highlight this in red here. It says, how tall is a nearby street sign? And that's really all we care about. Right? So everybody, what are we looking for here? We're looking for street sign. We're looking for the shadow. What are we looking for? Right. We're looking for how tall that street sign is. We're looking for how tall that street sign is. And so let me write that down here again. Start the problem off. Snap your head right over to the question. How tall is a nearby street sign? Okay. So we want to say street sign equals blank feet tall. And I know feet because all of the answers literally say feet. So that's why I know it's feet. And then the comparison that they make is that, oh, right over here, it casts a shadow. How many feet long? That's right. The shadow is 21 feet long. So let me go ahead and fill in a letter for what I don't know. Everybody, what letter should I use for the street sign's height? Give me a letter. That's not S, because S looks like 5, so might not really work out too well. Yeah, you can use T or X or W. Honestly, when I don't want to think about it too much, I'll use X. If it's like an S or an O, just keep it easy. Now, let me leave that right there. Now, let's take a look at the information that we're given here, because we see here that it says 20-foot tall tree. So let me write this here. The tree right here is 20 feet tall. And how long is the shadow of that same tree, everybody? How long is that shadow? Come on, everybody participate here. Let's go, man. Everybody participate. Yeah, right there. It's going to be 12 feet long. That's right. 12 foot long right there. 12 foot long shadow. So 12-foot shadow. Now, notice how I color coordinated this. And this is for your benefit, obviously. But understand, as you keep working forward and keep working into this, you're not always going to have the luxury of color coordination. And that's okay. I'm using this to help you make the comparison here, make the connection. So when we take a look here, look at what's going on, everybody. I see that we have the height to the shadow, height to the shadow. Are we going to compare the same things in the same way? Absolutely. Watch this. X, again, that represents tall, divided by 21, which is the shadow, equals, and then you see here with this one, we got for the tree, let me just write the tree up here. Or excuse me. Yeah, whoops. Yeah, the tree right there. We're good. And that's going to give us 20 right there for how tall it is. And then over here is going to be 12 feet for the shadow. And we're good. And let me just write this on the left side over here. This is going to be for the street sign. So I really want y'all to really see this. Like, this is how beautiful it should kind of look. Or this is how, I guess, I don't want to say beautiful. Like, this is how fitting it should look. On the left side, we're talking about a street sign. On the right side, we're talking about a tree. Notice how on the top of both sides, we have how tall it is. On the bottom of both sides, we have the shadow. Obviously, my big old head's in the way right here, but I think we can all see that this clearly says shadow. All right. So Yes or no, everybody? Yes or no? Does this make sense? Are we comparing the same things in the same way? This is how right it should look. Thanks, Janice. Appreciate it. Yeah. Okay, great. And who else? Let me see. That wasn't even that many people here. Come on. I want everybody to participate here. Come on. Everybody. Let's go. Let's go. Does that make sense here that we have the right setup? Perfect. All right. So with that setup, hey, no worries, Maya. If you set it up differently, I'm going to show you a couple different ways that you could have set it up to get the same exact answer. I got you. But now that we're here, we're good. We can solve this. Let me go and just throw this here in black. X over 21 equals 20 over 12. So we have the setup. Everybody, can we simplify? Yes or no? Yeah, we absolutely can simplify. Exactly. So let me help myself out here. Everybody, what are 20 and 12 both divisible by? You can do 2, Aldine. You can absolutely do 2, but it's better to use the biggest number that you can. And 4 would be that number in this case. Yeah, it gives you less work. If you use the biggest number that you can, you give yourself less work to do. So if I divide both the top and the bottom of that right side by 4, that turns into, Ronald, thank you, working quickly there. That's going to turn it into 5 over 3. So now that we got that going on, everybody, do we even need to cross multiply and divide? Do we even need to? No, exactly. We don't need to. We don't need to cross multiply here. We're fine. We can just go ahead and do this. We can just go ahead and say, hey, 3 going to 21, what's the relationship there? 7, but what operation? Divide or multiply? What operation? Because again, you got to be consistent here. Times 7. 3 to 21 is times 7. So if I'm going from 5 to the answer, what's that going to be? We got to multiply by, exactly, multiply by 7. And that's what's going to make x equal 35. So when you check that out, anybody here get 35 with a different setup? Did anybody here get 35 with a different setup? Yeah, and that's going to happen. That's going to happen. So let me show you all of the different ways that you could have still set this up. Let me show you right here. So all I got to do is just look at my original thing here, and I can make them all from that 1 right there. I can make them all from that 1 right there. So one way that you could have also set it up could have been, x over 20 equals 21 over 12. That's one way you could have also set it up. Another way you could have set it up could have been in the following way. You could have done 21 over x equals 12 over 20. Shot yourself out once I put up the one that you did. So there's one way here. Let me go and make that smaller. Give myself some more space. A little smaller there. Here's another way. Another way would have been, let me use blue here. Another way would have been, there's so many different ways, honestly. You can do 20 over x equals 12 over 21. That's another way you could have done it. Another way, let me see here, is there any other way? There should be at least one more way, I think. No, it will just be flipping the fractions. Yeah, it's all the same thing, really. But those are all of the different ways that you can set it up. Those are all the different ways. So does that make anybody here feel a little more comfortable about doing it the right way? Cool. Yeah, all of these different ways, you can still get the same answer. Every single one of those ways, you can still simplify and still see that comparison there. So remember, guys, set up, simplify, and solve. That's how you want to do it. Set up, simplify, solve. I read it right there. So Emmy, let me go ahead and give you that mic right there. What's up, Emmy? How you doing?
I'm good. So I just had a question.
Yeah.
Would this be an okay one to do an educated guess, since the 20-foot tree cast a 12-foot shadow, and if the shadow for the sign was 21, then it would have to be 28 or 35, correct?
Absolutely. That's a great way to look at it.
Okay, thank you.
Yeah, you're welcome. So yeah, if you're running out of time and you want to take an educated guess, yeah, that'll work. Yeah, I'll take one more question here. What's up, Jose? Let me go ahead and give you the mic right there.
Coach, I have a question. Like, not I know in this problem it's asking you what is for, well, S or X, but would they ever give you a problem instead of asking for what is for X or S, like the shadow, the sign? Would they ask you for like for example, like 7 instead of like the letter?
Well, if you ask me for 7, then the answer is 7. I'm not quite sure. I think that you're going with a different angle here in terms of,
Like, say they, instead of they're asking you for the shadow or the like right here, they're asking you for how tall is the sign.
right.
But would there ever be a problem instead of them asking you for the sign, they'll ask you for like how you did right there, 7, instead of the sign, they'll ask for you like what is the
Oh, what's the ratio? Like, what's the comparison? Yeah. They can ask you that. Oh, so yep, great question. They can
that's what I wanted to know.
Those are ratio word problems, and ratio and proportions. Like, if you understand proportions, you understand ratios. And we'll get into that in another class, absolutely, because that's a definitely easier topic. It's super easy, honestly. All you got to do is just know how to simplify fractions. That's really it. But we'll go over that. But let's go ahead and dive in, gang. We have more to go. We got more to go. Here's another one, man. Here's another one. I'm going to give y'all exactly 2 minutes starting right now. Remember to type ready when you're ready. Gene, go ahead and type your question in the chat box. I got you. Let's get it to it, my party people. Hey, Gene, that would work. Yeah, you're good. We got about 30 seconds left. If you already have an answer, tell me if you're confident. Mario, are you mad confident or dumb confident? I love that question. What's the difference? Like, which one is further, mad far or dumb far? All right, so let's go ahead and get to my party people. 3, 2, 1, let's go. Everybody type in an answer. And if you were able to get the setup done, even though you didn't get a number for the answer, let me know if you were able to at least get the setup. Go ahead. If you didn't get an answer, but you were able to get the setup, let me know if you got the setup. If you believe you got the setup right. Hey, that's what's up to me. That's what's up. All right, so yeah, let me know if you got the setup. Because again, look, today is not about getting the answer and being like, oh yeah, we're good. Like, no. It's about learning and growing step by step. So again, the setup is the most important part. That's step number 1 if you want to gain that confidence. Let me walk through this problem here. I got you. Kiara, I'll take your question right after. If you still got it, let me see if I can answer your question beforehand here. So let's go ahead here. I'm sure you guys heard that. If my connection goes out due to this thunderstorm right here, just make sure to stay in the class. I will rejoin using a hotspot. So don't worry, guys. So here we go, my party people. So here we are asked, how many cups of milk did he use? Okay. Highlight the question first here. How many cups of milk did he use? So all I'm going to start off with, my party people, all I'm going to do is I'm going to say, hey, I'm looking for blank cups of milk for what information is related to those cups of milk, everybody? What information is related to it? But what number though? The 50, what? 50, the number of pancakes, exactly. And the number of pancakes was 50. Yeah, the number of pancakes was 50. We got to be specific here because there's pancakes right here too. So you got to be careful about what information you use, and it's going to be 50 pancakes. So right over here, 50 pancakes. That's it right there. 50 pancakes. All right, cool. So everybody, what letter should I use for the answer here? All right, I see a lot of P's for pancakes. So we'll just go ahead and use, wait, what? You want to use P for milk? I'm going to use M. I was like, wait, hold up. I just had like a dumb moment real quick. I was like, what? No, let's go and use M for cups of milk. Again, this is M for milk here. For milk, okay? So let's go ahead, snap back to it here. I was like, what the heck? All right, so going back here, when you look at the information, it says a giant pancake recipe calls for 6 cups of milk for every 15 pancakes. So if I'm looking at that correctly, let me make sure I compare the same things in the same way. So I'm going to use blue here for cups of milk because I already used blue for milk right here. So I got 6 cups of milk for, and then it says 15 pancakes. So there it is. All right, cool. And so when I set this up, everybody, like there's again 4 or 5 different ways you can set this up. It's fine. Here's one way to set it up. If you would have compared milk to pancakes, you would have gotten M over 50 equals 6 over 15. That's one way to set it up. Shot yourself out once I set up the way that you did it. So there's one setup. Here's another setup that you could have done. You could have said M over 6 equals 50 over 15. That's another way you could have done it. Another way you could have done it could have been 15 over 50 equals 6 over M. There's another way you could have set it up. Another way you could have done it, one last way before I solve this, is you could have done, again, there's so many different ways you can do it. You could have done 50 over M equals 15 over 6. That's another way. That's the last one I'll do. But again, there's a bunch of different ways. As long as when you set it up, you're comparing cups of milk to pancakes in the same way, you're good. You're absolutely good. So let's go ahead and take the time here and solve. That's some loud thunder. So with that, here we go. We got M over 50 equals 6 over 15. We got the setup right. Now let's go ahead and actually solve it. Oh, before we solve though, what's the question we have to ask ourselves? Can we what now? After we set it up, but before we solve, can we what? Who knows? Simplify. That's right. Thank you guys for paying so much attention. That's what I love to see. There we go. Can we simplify? And the answer is yes. Everybody, what are 6 and 15 both divisible by? What are they both divisible by? Yeah, they're both divisible by 3. They're both divisible by 3. Let's go ahead and give ourselves that little helping hand right there. And so, boom, everybody, we got M over 50 equals, what's 6 divided by 3? Everybody, quick, let's go. That's going to be 2. And then 15 divided by 3 gives me 5. That's right. So let's go ahead and put ourselves in the best position to succeed, everybody. Is it clear here that we can actually do a comparison here pretty quickly without actually having to cross multiply? Yeah. Yeah. We're feeling pretty good about that. Because if you take a look here, oh, if I go 5 times what? Yeah, 5 times 10 gives me 10, or 50, excuse me. 5 times 10 gives me 50. And so that means that 2 times 10 is going to give me my answer. What's my answer then, everybody? M equals what? Yeah, 20 what though? It's a word problem. 20 what? That's right, 20 cups of milk. 20 cups of milk. And that's how many cups of milk you need for 50 pancakes. And so boom, there it is. And that's why the answer is C. Shout yourself out if you got the correct setup or you get the correct answer. Either one, shout yourself out. We're feeling good about it. Let me go ahead and give Kiara that mic. What's up, girl? What's your question?
So correct me if I'm wrong. This is what I did. I really did not pay attention into, I didn't pay attention to the numbers. I paid attention to the words. Is that okay?
Yes, that's exactly what you need to do. Yeah.
Okay.
Yeah, because it's not about what the numbers mean, it's about what they represent.
Okay.
Yeah, great way to look at it. Great way to look at it. Maya, what's up, girl?
I set mine up 6x equals 6 over x equals 15 over 50. But I get lost on the simplifying step.
I'll show you right here. I got you. So look at this right here, Maya. You went 6 to the answer. Let me use a different color. Let me use a highlighter. So you went 6 to the answer to x, 15 to 50. Notice how you compared the same things in the same way?
Yes.
Bottom to top, bottom to top. You're good. You got it. That works.
Okay, but I keep getting lost on the simplifying.
So then we want to write that down then. So here's the topic that you want to work on. The topic is called simplifying fractions. So I'm going to go ahead and write that out for you. Let me use red right here. So simplifying fractions is a topic that you're definitely going to want to work on if you want to be able to look at this with a little more ease. I got you. So you can YouTube this. If you're in my program, you got plenty of practice for this and classes too. So write that down if that's something that you see that you need to work on for sure.
Okay.
And then Mikhail, and then we're moving to the next question. What's up, boss?
Okay, so like I'm getting where you're saying to simplify for a smaller number, because I did like the 6 over m equals 15 over 50, and I divided the 15 and the 50 by 5, and I got 3 over 10. And then I multiplied the 3 and the 10 by 2, and I got 20. But I get what you're saying. By using a smaller number, it's easier to work with.
Yeah.
Because like the whole time I'm sitting there, I'm like, okay, am I doing this right? Like I second guess myself. I mean, I got to the answer, but I don't feel sure when I'm putting in the equation properly.
Yeah, so right here, when you did the 15 over 50, you divided them both by 5, and you ended up getting 3 over 10 equals 6 over m. And if you're looking at this, you're basically saying, oh, okay, 3 times 2 is 6, 10 times 2, that's 20. Right there. Yeah, that's exactly how you do it, man. Again, using those numbers to simplify, again, allows you to see that convenient situation. And even if it doesn't, look, let me be honest with you. Even if it doesn't, everybody, you still get to do the cross multiplication and division with simple numbers, not 2, 3 big numbers, but 3 smaller numbers. And that's the point of it. That's why you want to simplify always, 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 always. Gene, let me go ahead and find you in the list here. All right, Gene, go ahead.
Hello, can you hear me?
Yeah.
So the way I do it, coach, is I put 6 over x and then 15 over 50. And then I do the math. I got like 300. And then I do the equation, divide both sides by 15. And then dividing 15 by 200 by 50, right?
Mm-hmm. Yeah, and you would have got that right. But the fact of the matter is, I probably could have opened Facebook, checked like 10 people's feeds, and then put my phone down by the time you were done. Like that's the idea behind it. Like you can save a lot of time by understanding simplification methods.
Oh, okay.
Yeah, that's all it's about. Like it's all about simplifying and saving time. That's really what it's about.
Oh, okay.
Yeah.
Thank
So,
you.
hey, great question though. They're still correct. Oops, let me go ahead and lower your hand. All right, my party people, let's go ahead and go to the next one here. Let's jump right in. 2 minutes, 3, 2, 1, let's go. And remember, gang, the setup is the most important thing here. The setup is the most important thing. 3, 2, 1. Take a shot here. Take an answer here. Put a question mark next to your answer if you are taking a guess. Let's go. Let's go. Let's go. Yeah, and again, I know time is definitely going to be a big issue here. So that's why I only care about the setup in these first 2 minutes. I only care about the setup here. Let's go. Take a guess if you need to. Take a guess if you need to. I see some people private messaging me here like, I don't know. Can I guess? Yes, you can guess. Absolutely. Some people saying I'm scared. Hey, again, that's part of the process. It's part of the process, facing those fears and understanding that there is a way forward as long as you're being honest about it. So let's go ahead and get to it, my party people. Let's go. So everybody, what are we looking for? Type it out. What are we looking for here? Before I even highlight it, what is the question asking us to find? What are we looking for? What are we looking for? Let's go, let's go, let's go, let's go, let's go. The amount paid, but for what? Let's try to connect the information simultaneously here. Like, because is there information connected to how much we're getting paid? Great job, Aldine. Yeah. How much are you getting paid for 30 hours of work? So we want to make sure we're specific there and really snap our head over to that request here. So how much should be paid? And that's connected to 30 hours of work. And so we can write that down. So blank dollars for 30 hours of work. And so we can write that out right there. How much money we get paid? 30 hours of work. Cool. Nice and sweet, nice and simple. Now, give me a letter, everybody. What letter should I use for that blank there? Give me a random letter that will work, that'll fit. And we use W for wage. That's fine. Yeah, W for wage. That's fine. Just don't think too hard about it. There it is. Now let's go ahead and look over the information here that we're given. So everybody, should I highlight $42 in red or blue? Quick, quick, quick. Red or blue, red or blue, red or blue, red or blue. Mario Green. We're going to do red here. It's going to be red because the amount that we're getting paid right here is in red. So to keep the same comparison, let's just go ahead and do it in red as well. So we have $42 right there. And for how many hours of work? 8 hours right there. Boom. So $42 for 8 hours of work. All right, so there it is. There it is. There it is. And Adam, to answer your question, yeah, you can use whatever letter you want. Honestly, it doesn't matter. Just to make sure that you know what you're doing while you're doing it. That's it. That's it. Whatever makes you more comfortable. So here we are. We got W dollars for 30 hours, $42 for 8 hours. So a setup that you can use. I'm just going to go ahead and compare it like this. W over 30 equals 42 over 8. Again, as long as you're comparing the same things in the same way, you are fine. I'm going from wage to hours, wage to hours. Again, as long as you compare the same things in the same way, you're fine. You can go wage to wage, hours to hours. That works. You can go hours to wage, hours to wage. That will work. What won't work is going from wage over here to hours over here. That won't work. You can't cross compare. That's not a really, no. You can cross multiply, but you can't cross compare. So we have W over 30 equals 42 over 8. I'm looking at this, and it's not super easy from the beginning, but again, is there something we can simplify in the 42 over 8? Is there anything we can simplify? What can we simplify, everybody? What can we simplify? Who knows, who knows, who knows? What can we divide both the top and the bottom by here? Two. It's going to be 2. We can divide both the top and the bottom by 2. So if I divide both the top and the bottom by 2, what we're going to receive here is still the same thing, W over 30 on the left side. And on the right side, what do we get? So we got 42 divided by 2, that's 21. 8 divided by 2, that gives me 4. All right, cool, we're there. Now we got 21 over 4 Now you're looking at this and you're saying, okay, 4 to 30. Do I know how that goes? Well, let me explain. Everybody, yes or no, would you want to do 30 times 21? Do you want to do that? No, we don't want to do that. We do not want to do that. We absolutely do not want to do that. That is not what we want to do. No, 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 no. Let me show you how to do this, my party people. So remember, the theme of today is compare the same things in the same way. So top to bottom, we divided both by 2. That works. Let me show you a little secret here. Instead of doing 30 times 21 and 4 times W, simplify. Everybody, what can go into both 30 and 4? What can go into both 30 and 4? Yeah, 2. And if I wanted to, remember with equations, everybody, as long as you do the same thing to both sides, you're good. You're good. So watch this. Divide by 2 and divide by 2. If I do that on both sides, what do we get? We get W over that, 21 over that. Everybody, 30 divided by 2 is what? 15. 4 divided by 2 is what, everybody? That's going to give you 2. Okay, great. So when you're looking at this, now you may be looking at this like, okay, is there anything else that I can do? Well, the answer to that is no. That's as far as you can go. So let me be very real with y'all. This is as far as we can go in this situation. Now, what should we do in this case? If this is as far as we can go, what's the action we should resort to now? Yeah, Mario, correct. Cross multiply. Now is the time to resort to cross multiplying. Now that we're doing cross multiplication, notice that we are not dealing with 30 times 42 and W times 8. Now what we're dealing with is a lot easier of a situation because everybody hit me up. W times 2 is what? W times 2 gives me what? Yep, W times 2 is 2W. And then we have 15 times 21, 15 times 21. Okay, we got to do a little bit of work, and that's fine. We'll do it. That's fine. Ain't no problem. All right, so 1 times 5 gives you 5. 2 times 5 gives me 10. Great. Bring the 0 down. 1 times 1 is 1. 2 times 1 is 2. Add them together, and we get 5, 1, 3. Okay, so we got 315. Sounds good. So we got 315 for that right there. Everybody, what's the last step? What do we got to do to both sides? Ashley, absolutely. It could have been. That's right. Divide 2 on both sides. Divide by 2 on both sides. That would be it. And so we're going to divide by 2. Divide by 2. Booyah right there. So that's going to leave W. 315 divided by 2. Hey, that's fine. We can go ahead and do that here on the side. All right, so let's go ahead and do it. No problem. 2 goes into 3 one time. Everybody, 2 goes into 11 how many times? That's right, 5 times. So minus 10. Do we even need to finish this? Do we even need to finish this? Nope. We don't. Because look at this. This starts with 1, 5. Which answer starts with 1, 5? Done. Let me go ahead and show you right here. With the ASVAB arithmetic reasoning, you do not always need to solve the problem completely. You don't always need to. Honestly, you could have started literally right here. Everybody, look at the 2W equals 315. If you look at the 2W equals 315, you know you got to divide by 2 on both sides. Everybody, answer me this quick as you can in the chat box here. As quick as you can. Everybody, what's 300 divided by 2? Go. What's 300 divided by 2? Go, 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 go. 300 divided by 2 is 150. A lot of people here knew that. A lot of people here knew that. And so when you think about it, if you're doing 150 divided or 300 divided by 2, but you're doing more than that, you're doing 315, doesn't the answer have to be more than 150? Yeah, the answer has to be more than 150. And you can look at this and say, yep, looking at the answers real quick, we're good. I don't have to torture myself. I don't have to go through the whole work here. Again, the point of every question is to get the answer correct, not to show all of your work. No, that's why I always explore mental math strategies. I always explore different ways of looking at the problem to give yourself as much of an advantage as possible. You're bending the rules here. That's okay. Because if you know what you're looking for, you know what to do. Absolutely, Reese, take a screenshot, girl. You're good. You don't need to do all the work. You do not need to do all the work here. So take your screenshot. All right, we're good. So let's keep practicing here. I'm going to skip over to this next one over here. I would love to go over this one here. So go ahead. I'm going to give you actually 2.5 minutes here. And I'm going to give you a warning right now. This problem right here is about total, okay? Let me make sure you guys understand this completely here. This is a total problem. Now, what do I mean by total problem? Check it out. They give you the ratio. They tell you boys to girls. So boys to girls is 3 to 5. So they give you the ratio right there. But then they tell you that there are 104 total students. So I'm going to leave that hint for you. I'm going to give you the 2 minutes starting now. I'm going to see who can figure this out. I'm going to see who can figure this out here. This is an example of a total problem. You will absolutely see a problem like this. Here we go, starting the timer right now. Let's see if we can get the setup correct. Go. So there's my advice right there for the setup. That I'm going to show you exactly how this makes sense. Just do your best here. That's all I care. Just do your best. My God, I was muted the whole time. Go, give your answers. Go for it, go for it, go for it. Put a question mark, take a guess if you need to. That's all good. Take a guess if you need to. It is all good, man. Let's go. Again, this is going to be honestly pretty eye-opening once I show you how to tackle a problem like this. Because you're always, you're going to have your problems where you're doing part to part relationship, like boys to girls. Oh, find boys compared to girls again. There's going to be so many problems like that where they say street sign, height to shadow. But let me introduce you to total problems. All right. Let me introduce you to total problems here. So everybody, first off, what are we looking for? The total number of students, boys, girls, what are we looking for? Right, we're looking for girls, right? We're looking for girls. Cool. We're looking for girls. Right there. How many girls? Cool. So we're looking for G girls. And there are, and what were they giving us? What did they give us? They tell us, hey, find G girls, but what did they tell us with that information? Like, what did they attach to the number of girls? Aldine, right? They give us the total number of students. They attach, again, in the same sentence, if there are 104 students on the trip in total, how many girls are there? So notice how it says 104 students in total. So let me write that there. 104 total students. So let me really make this make sense, guys. Like, let me actually show you what's going on. So if I wanted to make a proper proportion, like a good proportion to actually be able to use this, let me just show you. Let me walk you through. I got you. So over here, I'm going to set it up. G over 104. So remember, everybody, G represents girls and 104 represents total. Now, I'm going to ask everybody right here, because I know that there's like half of us here that are stuck. We're looking at this and we're like, I'm not quite sure what to do. Everybody in the chat box, type it out. Proportions. What is the cardinal rule? What is the cardinal rule? What is that sentence that I said from the very beginning of class? Type it out. Go. I'll wait. I'm going to blow y'all's minds. Let's go. Right. I mean, you're crazy. Go ahead. Compare the same things in the same way. Type it out, everybody. Type it out. Type it out. Type it out. Compare the same things in the same way. Yep. Everybody. We got a couple more people to go. Come on. Compare the same things in the same way. Let's go. That's right. So let me open your mind here. I got you. If I wanted to go ahead and set up the proportion, again, this is what I wrote right here for y'all. For the setup, start with what you need. So what I need, G girls, 104 total. Now, I'm going to write the other comparison in the same way. This is way too important there. Write the other comparison in the same way. Watch this, everybody. So in the information that I have right here, the 3 to 5, what number represents girls? Go. Correct, 5. We got 5 girls. Right there. I tell you right there, that 5 represents girls. You know that because they say boys to girls, and they write it in order. 3 to 5, boys to girls, boys to girls. So we got 5 girls right there. Now, here's the question, though. Everybody, did they tell you what the total was for this part of the problem? Did they tell you, like, what the total was? Aldine says no. Who agrees? Who disagrees? Ronald says no, but it is 8. Jenny says no, but it's 8. Ooh, I know my party people that attend my classes. I see y'all. Let me go ahead and show you something really quick here. Notice how if I were to put 3 for the boys, if I were to use that number right there, if I were to use 3, everybody look at it. If I put the 3 for the boys, are we comparing the same things in the same way? No, we're not. We're not. Take a look there. Look at the colors. The colors don't match up. The top part does. Yeah, girls and girls. Yeah. But what about the bottom? We have 104 total and 3 boys? That makes no sense, right? That makes no sense at all. And so because of that, if you use this setup, you would have been wrong. You would have been wrong because you're not comparing the same things in the same way. Did anybody here set it up that way? Be honest. Anybody here set it up that way? Cool. And thanks for being honest. Yeah, thanks for being honest. Thanks for being honest. And that's cool. That's fine. But that's incorrect. And let me show you the true way to get it. The true way to get it, again, would be to play off of the answer that you're trying to find. I have G girls and 104. Again, it's about what the numbers mean. Total. That 104 represents total. So if I got 3 boys for every 5 girls, what's the total number of people that we're dealing with in that case, everybody? What's the total? Everybody type it in. What's the total that we're dealing with? If we got 3 boys to every 5 girls, the total that we're dealing with, that's right, 8 total is what we're dealing with. 8 total is what we're dealing with. And so because of that, now we can keep comparing the same things in the same way. I can write 8 total. And now that we look at this, everybody, are we good now? Is this correct now? And that's what I mean by party people. That's what I mean about really, again, spending all the time that you need to set it up. Because if you don't set it up the right way, you're bound to get the answer wrong. You're bound to get it wrong. We have to set the problem up the right way. Now that we have girls to total, now we're good. Now we can take care of business. And so that's exactly what we're going to do. I'm going to take care of business here and go ahead and do my thing. So when I look at this, I'm saying, okay, 5/8. I'm not sure if I could really simplify that really easy. Is there a way to simplify the 104 and 8? There is, but let's pretend that you didn't know that, because obviously not a lot of people here did. So let's just go ahead and do the cross multiplying and dividing here. That's fine. So Jose, the 8 comes from adding the 3 and the 5. Again, we need the total here, right here. That says 104 total. Remember this, we got to keep looking at what the numbers mean here. The 104 means total. If you would have put 3 there, that wouldn't have worked. Here you have 3 boys, 5 girls, so the total is 8. The total is 8. All right. The situation calls for this one, Kiara. The situation calls for us to add them to get the total. It's not always going to be the case, just like you saw earlier with the street sign, the height, and the shadow. Sometimes you don't need to. But here you did. And that's why it's too important to read the wording, not the numbers themselves. So now that we're here, we can just go ahead and cross multiply and divide, and we're good. So cross multiply here, we'll get 8 times G. And then we have 104 times 5. What's 104 times 5, my party people? As Zoom user, go ahead and type it out. I got you. Yeah, that's right. 104 times 5 is 520. A quick little thing of mental math. Let me show you. Because 100 times 5 is 500. 4 times 5 is 20. And that's how we get 520. And then lastly, we'll divide both sides by 8. And boom, we get G equals what? Okay, let's go ahead and actually do our math here. And we can go ahead and do 8 going into 520. 8 goes into 52. That's going to be 6 times. And so we subtract 48 to get 4. Bring that 0 down. And 8 goes into 40 5 times. And so we get 65. And that's how we get it as the answer. G equals 65 what, everybody? 65 what? That's right, 65 girls. That's right. 65 girls. And there it is. And that's why D is the correct answer. That's why D is the correct answer. And so, yes or no? Did that make more sense after the fact, after I showed you the whole total relationship there? Does that make a little more sense after showing you that? Because I'm telling you, man, like, this is the best example that I can give you in terms of, hey, it's not about what the numbers are, it's about what they mean. I'm telling you, like, that is the biggest thing that I can ever say to anybody. That's it right there. So I'll take a quick question from Mikhail, and then I'm going to wrap things up where I'm going to show anybody here who wants to join the full program and likes what they saw today. I'm going to go ahead and talk to you about it real quick. But Mikhail, go ahead. What's your question, boss?
Okay, so when I did that, I did like kind of like a process of elimination, and that's how I got like 62. But yeah, I get what you're saying now because it was about what information that you had, just trying to figure out what the ratio was. So.
Yeah, it's about getting the right setup, man. Again, before you can solve, you got to set it up the right way. That's really it right there. So great question. Adam, what's your question, boss? Oh, you already asked it here in the chat box. So Adam asks, why would you put girls instead of students? Did students 104 instead of girls over 108? No, if you went over it the other way, you can still set it up that way. Yeah, you can do 104 over G. You would just have 8 over 5. That's it. You had 8 over 5. Just to set it up the right way, because you would have over here, total over girls, total over girls. That's it. And students, you can say total students. Yeah, that works. That works. And so with that said, my party people, look at 7:55. I'm going to cut it short just a little bit here, but I got to ask y'all, man, like, what was the most important piece of information for y'all here? What was the most important piece of information here? Go ahead, shout it out before we go. And if you're in the All-Access Pass, remember, we have a class tomorrow and Wednesday. If you're not in the All-Access Pass, stay for a second. I'm going to show you how to join my classes, affordable as heck, and really raise your score the right way, you know? So let's look at these. The setup, the wording, comparing the same things in the same way, the setup, the ratio. Janice, yeah, you've come a long way. That's what's up. The setup, to read, to understand the numbers. I love this. The setup, the ratio, the setup and the ratio. Yes, sir. You too, Adam. You've come a long way, man. The wording, the setup. When it comes to the total equation setup and understanding the details are so important. Look at that. Aldine, yeah, it's going to be on Wednesday. I messed up. I just fixed the calendar right now. So if you check the schedule, it's good now. I thought I had jury duty on Wednesday. It's actually Thursday. So I had to switch it real quick. That was my fault. I got my assistant to fix it all up. But there it is, my party people. And so hey, thanks for watching. Go ahead and smash that subscribe button up here. That way you can get more great content from us, or text ASVAB to that number. That way you can join us for a free class and get a free mini course at the same time. And then look forward to the next video. That way you can continue crushing it and raising your score. Anderson, your ASVAB coach here. See you next time.